Assalamu alaikum, guys. The topics of today's lecture is quadrature carrier multiplexing or quadrature amplitude modulation. So, QAM. So, the title is quadrature carrier multiplexing. So, this is also known as quadrature carrier multiplexing, or it also termed as quadrature amplitude modulation. Quadrature modulation. Quadrature amplitude modulation. So, in this actually, quadrature carrier multiplexing or quadrature amplitude modulation scheme enables two double sideband suppressed carrier modulated waves. I mean, resulting from the two independent message signal occupy the same transmission bandwidth. That's actually whenever. So, why actually it is used in the double side band suppressed carrier in this application where two independent message signal occupy the same transmission. So, one message or two independent message in a single transmission bandwidth, means single channel is using. Okay, so it is actually one of the bandwidth conservation scheme or multiplexing technique. Okay, so let us assume consider two carrier signal because there is a multiple of carrier here. This is used in the double sideband suppressed carrier to transmit two message signal by using two different carrier. So let us say, let's say consider two carrier signal. So they can be either like for example cos 2 pi fct, or they can be sine 2 pi fct. So here we can see sine and cosine, they are actually 90 degree apart from each other, right? In phase. For example, if I write cos 2 pi fc, I can write it in a terms of sine, right? Sine 2 pi fct plus actually pi by 2. That's actually nothing. So if I compare this carrier and with this carrier, they are actually 90 degree phase shift. So the difference between 90 degree phase shift, right? So phase difference of these two carriers are so phase difference is pi by 2 or 90 degree phase shift between these two carriers. Hence, because they are two carriers are 90 degree apart from each other, these two carriers are called quadrature. These two carriers are quadrature to each other. Quadrature. Quadrature is nothing but pi by 4. That is called quadrature, right? For example, if we draw a like angle diagram. So this is 0 degree, this is 90, 180. So you see each one individual is, this is a one quadrature, this is another quadrature, this is another quadrature, means actually 90 degree. Here is 90 degree, here is 90 degree, here is 90 degree. Here. That's why 90 degree is actually termed as quadrature, because these two carrier are 90 degree apart from each other, pi by 2, so they are called they are called quadrature. Okay, so uh, say, so this say a message signal. So let us say a message signal, we want to transmit a message signal. So let's message signals are same as, like we want to transmit two message signal. So let us transmit two message signal. Message signal M1 and M2. These two message signal will be used in our DBBS scheme, right? That actually we discussed earlier, that this is our intention to transmit two message signal. So that's the transmitted signal xt can be written as AC M1T. So this is one of the message which is actually multiplied by the one of the carriers, so cos 2 pi fct, and the another message is AC M2T sine with another carrier, right? Sine 2 pi fct. Okay. So here two message signal M1 and M2. So we can transmit through by combining them, right? Message signal. Okay, so the message signal will be modulated. One message signal will be modulated by this carrier, and another message signal will be modulated by another carrier. That is actually the idea. Okay. Okay. Now we will M1 is actually here. We can see that M1 is modulated by this cos 2 pi fct. Okay, so we can say that this is actually in phase carrier, this one, in phase carrier. So we can say that M1, so M1 T is the message signal, is the message modulated by cos 2 pi fct. Okay, and M2T is the message modulated by sine 2 pi fct. This one is actually the in phase carrier. Okay, in phase carrier, and this is actually quadrature carrier, which is actually a 90-degree area apart quadrature carrier. So this is actually quadrature carrier. So sine theta is pi fc. This is actually the quadrature carrier, and cos is the in phase carrier. Okay. So now what we will do, we will actually these two messages M1 and M2, they will be multiplexed or multiplexed by quadrature carrier. Okay. So two message M1 and M2 multiplexed are multiplexed. They are multiplexed on quadrature carrier, means two carrier. They are quadrature to each other on quadrature carrier. Okay. If this is the case, then this scheme is called quadrature carrier multiplexing. So this scheme is called, so this scheme is called quadrature carrier multiplexing, or this is also termed as quadrature amplitude modulation. Okay, so quadrature carrier multiplexing is actually the topics of today's discussion. So now what we will see that, okay, we multiplex, right? Then we will demultiplex. Okay, so if this is the case, let's see how the transmitter looks like. Okay, how the transmitter looks like. Let us see. So the transmitter, how the transmitter. So you have a message signal, message M1, one message. So this message will modulate, right, by in phase modulator. So okay, so we will actually multiplex it, multiplied by in phase modulator. So this is actually a in phase modulator, which is actually AC cos 2 pi FCT. This one, with this one, in phase carrier. Okay, in phase carrier will modulate the message M1. So when it modulates, so we call it product modulator. Product modulator. Okay, you see they are in product, means they are in product term. So if you have a signal, then this signal goes to your product modulator. Okay, now you can see this. If you cos twice by FC, if you have pi by 2 degree phase shift, then it becomes the sine 2 pi FCT, right? So we will actually use a phase shifter here, 90 degree phase shifter. Okay, so to modulate the another one, another message, right? So this is actually 90 degree phase shifter. So the 90 degree phase shifter actually do what? It actually modulates another message, which is actually message M2. Message M2. So this signal, when it comes here for this product modulator, this actually cause when it phase shift 90 degree, this actually here it becomes actually AC sine 2 pi FC, right? Because of this 90 degree phase shifter. This is this phase shifter. It becomes 90 degree and or it becomes quadrature. So this is also a product modulator. Modulator. Then what do we do? We actually combine them. The output of this product modulator, they are actually combined with a combiner. Okay, and it actually multiplexed. So this signal is multiplex signal. So multi signal. That signal we actually transmit. Okay, so this is actually a schematic diagram. So this is actually a schematic diagram of this is actually a schematic of quadrature or QCM transmitter. Okay, modulator or demodulator or multiplexer actually. Scheme diagram of QCM multiplexer. QCM multiplexer. Or the it's actually QCM transmitter. Okay, now we are multiplex this signal, we transmit this signal, say. So how to demodulate or demultiplex it? Okay, now let's demodulate this signal. Okay, we modulate this signal or demodulate with. Now let us demodulate or demultiplexing. Demodulate, demodulate, or demultiplex it. Demultiplexing this QCM. So while demultiplexing, let us so we receive this signal, multiple signal, where we have the both of the signal, message signal as well as the message 1 and message 2 with a in phase or quadrant phase multiplex. This one, xt. So we actually receive xt signal here. So this signal actually xt. This is our signal xt. Now we receive a signal xt. Okay. So we receive a signal xt and we demodulate it by one of the carriers. So we say demodulate by demodulate by one of the carriers. Right? So first carrier is cos. So cos 2 pi fct. We will demodulate it by this one. So what happened? So the xt signal will demodulate by cos 2 pi fct, like with one of the carrier. Okay, so if this is the case, then what is xt? Xt is nothing but ac m1 t cos 2 pi fct. Okay, minus ac m2t sine 2 pi fct. This multiplied by with cos 2 pi fct. Okay, so here we can have two formula. Okay, this cos multiplied with the cos term, so cos square theta, and this will be sin theta cos theta. So if it's cos theta cos term, then 2 cos square theta equal to 1 plus cos twice theta. So 2 cos square, because 2 is missing, so it will be half ac m1 t, right? So cos and cos square theta, but I want to make it 2 cos square theta, like 2 cos square theta equal to 1 plus cos twice theta, because this 2 is not there, so I will make it half. Okay, half 2 cos 1 plus cos twice theta. This is already cos 2 pi, so this is actually cos, for example, 2 of 2 of let's say pi twice fc t. I want to write twice fc together. That's why. So this is 1 plus cos twice theta minus cos theta minus sin theta, right? So it will be acmt by 2 sin theta sin twice theta. Sin twice theta equal to sin theta cos theta. So like sin twice theta equal to sin theta cos theta, right? So I will write sin 2 pi twice fc. Same thing, I want to write it twice fc separate to indicate what? To show that, okay. Now you can see that this is twice fc, twice fc. Our initial frequency was fc. So this 2 term becomes in twice fc. This is very high frequency, right? So if I band past it, right? After this signal, we pass through a low pass filter. Low pass filter, then higher frequency will be cancelled out. So you see, this term will cancel out, this term will be cancelled out. What do we have? We only have this term. Only this term, right? So this term. What is this term? After passing it to the low pass filter, this is actually the baseband signal, right? This is nothing but the baseband signal. Our message signal, message signal is here only, baseband. So this is actually our baseband. So if we do modulate by one of the carrier, we find M1. You see, M1 was with which carrier? We modulate it by which carrier? M1. This M1 signal, we modulate it by this term. So if we demodulate the whole signal by the same carrier, we can recover this same message. Again, if we demodulate the whole xt by this carrier, we'll actually receive this message. Let us see. Okay, this will be the same. So we'll just repeat it. That okay, demodulated by, now demodulated, demodulate by another carrier, sine 2 pi fct. Okay, let's see what it come. So demodulated by, so xt signal we demodulated by the sine signal. Okay, sine 2 pi fct. Okay, sine 2 pi fct. What is xt? xt is nothing but our receive signal a cm1 t cos 2 pi fct minus cm2 t sin 2 pi fct. So this signal will be multiplied by the sine 2 pi fct. Okay, so for the sake of derivation, we take it as a minus sign, which is actually same thing, only the negative sign. So what will happen? So sine and cos, so it will be nothing but minus ac by m1 t by 2 sine 2 pi into 2 fc t, right, plus ac m2t by 2 minus, same thing, by following the previous formula, ac m2t by 2 cos 2 pi 2 fc t. Same thing here. We can see that this is also a higher frequency, also a higher frequency. So we pass through a low pass filter. We'll have, we'll actually can cancel out this term. We can cancel out this term also. So this term will remain. So we will have AC M2T by 2, which is actually our baseband message. Baseband message. Baseband message M2 here, right? This M2. So by multiplying two different, or by demultiplexing or demodulating by two different carrier, we can actually receive the corresponding message, right? So if I draw the demodulator, okay, let us draw. So here we draw the modulator or transmitter. Here let us draw a receiver. How the receiver looks like, okay? How this receiver, so this is QCM receiver, let's say. How the receiver looks like. So previously we multiplex this signal xt. This xt, right? So let us receive this xt. So this is actually the multiplex signal xt. So imagine we receive the signal xt. This is nothing but the multiplex signal, right? This is actually the multiplex signal. So this signal xt, it's initially goes to two different product modulator, right? Which is actually this one. This xt is either modulated by this one or modulated by this signal, okay? Two different carrier, okay? So it is actually modulated by two different carrier. So it is actually modulated, right? So this is actually modulated by a carrier. For example, first one or in phase one is modulated by cos 2 pi fct, and the other portion is modulated by the sine, right? Product modulated. So other one is become sine by how 90-degree phase shifting, right? By 90-degree phase shifting. So here we'll actually this signal like this one, like this one. So this term they are actually passed through a low pass filter, right? The first modulated signal is passed through a demodulated signal is passed through a low pass filter. Low pass filter. Once you pass through a low pass filter, then you got the first message, which is actually AC. This one, ACM1T by 2. So you receive the signal, which is actually half ACMT. This signal, right? You receive this signal. And if you pass through the other one, this one, this signal, pass through another low pass filter, pass through another low pass filter, you actually receive half of ACM2 message. This one, ACM2 message. If you receive it here. Okay. So we see by in phase carrier by demodulator. So we can say this is actually our this is actually schematic diagram. Schematic diagram of what? QCM demodulator or receiver. QCM receiver or demodulator. Demodulator. Okay, so we can see that by the double sideband surface carrier signal can be transmitted to actually message can be transmitted through a single channel. Okay, by using two different. So we can say therefore using an orthogonal carrier, two parallel message can be transmitted on the same channel. So we can say what we can say that using orthogonal carrier means in phase and quadrature carrier, they are orthogonal to each other. They are 90 degrees to if a signal is 90 degrees, so this is signal X, if this signal is Y and their phase difference is 90 degree, then they are called orthogonal. Same thing happened with our carriers also. They are orthogonal carrier. For example, cos 2 pi fct and sine 2 pi fct, which are 90 degree to each other. Two parallel message can be two parallel message M1 and M2 can be transmitted. Can be treated using the same channel. Using the same channel. Okay. So here one thing you can notice that when we express this message xt, you see when I write this message xt, this message two messages, this message when we transmit it, you see they are actually summed here in the transmitter or modulator, right? But when I write here, you can see that okay, you can see that I can actually use the subtract here like minus version. So it can be also like you can also summed up here. What will be the difference here? The only difference will be in our equation. For example, in demodulator, this sign, will be this would be a positive sign. If it if it like summation, then yeah, this will be just a positive sign. Like this is a positive, then this will be a positive sign. So it's actually same thing. So instead of that sign, then we didn't or we did not need to use this negative sign. That's all actually. So it's just mathematical convenience. Okay, so either can be used. Okay, that's all. Here we stop our lecture.